All right, one more example problem for the homework for you people who want it. So again, we're going to go through our steps, all 4 of our steps one by one. So does this graph open up or down? Well, we need to look at A, which is the number in front of the parentheses. It's just a negative sign, okay? So I know A is -1. This graph is opening down. The vertex, you look at the number inside the parentheses and the number at the end. Okay, the number in the parentheses, you take the opposite of it, and that is your x-coordinate, and then the number at the end is your y-coordinate. So we have a vertex at 2, -2, right here. That is our vertex. Find the y-intercept and its reflection. To find the y-intercept, you, instead of writing x in the equation, you write a 0, and you solve for y. So y equals negative. Instead of writing an x, you write a 0, -2 squared, -2, and you just solve the entire right side of the equation for y. So y equals negative. We have a -2 in the parentheses because 0 minus 2 is -2. Whoops, that's just supposed to be a negative sign. -2. -2 squared is 4. Okay, so we have a -4 minus 2. That equals -6. So we have a y-intercept at -6, right here. Reflection point. So remember, to get the reflection point, you'll have to find your axis of symmetry, which is just the x-coordinate of your vertex. So my axis of symmetry is this line right here at x equals 2. And then to find a reflection point, you look at your y-intercept and you count the distance to the axis of symmetry. So this is 1, 2 away from the axis of symmetry. So from the axis of symmetry, you count 2 on the other side, and that is the reflection point. So 4, -6. Lastly, we would need to find our x-intercepts. All right, and for my purposes right here, because I'm just focusing on graphing, I'm not going to actually find the x-intercepts for one reason. Okay, I know that this graph opens downwards, right? I already figured that out. So this graph is going to do this. It's going to look like this. Here's the x-axis. Okay, this graph is never going to touch the x-axis. So I know that the x-intercepts are going to be those I numbers, okay? Imaginary numbers. So normally I would want you to find those numbers anyways, but since we're just focusing on graphing, I want to focus on what we do if the x-intercepts don't work out, if they're imaginary numbers. All you do in this case is you create a table of values, an XY table, and you're going to plug in 2 numbers for X, and you're going to get their Y values, and then you just graph those points. They can be any X values, okay? So let's say I want a point at X equals 1, and I need to find the Y now. So all you do is you plug 1 in for the X in the equation and solve for Y. So Y equals negative, plug in 1 for X, and solve. So Y equals negative, 1 minus 2 is -1, so you'll have a -1 squared. -1 squared is +1. So we have a -1 minus 2, so Y equals -3 in this instance. So when X equals 1, Y equals -3. So there's a point right here. Now you could choose another X point to find another value here for Y, or you can use the same thing you did for the y-intercept and its reflection point. So look, I have an X value at 1, -3. Count the distance to the X, or to the axis of symmetry, which is 1, and then go 1 more from the other side, and there's my parabola. So that's how you do it when you have no